Hi, everyone. Thanks a lot for joining the Intelligent Apps with Azure Functions live stream. My name's Eamon O'Reilly. I'm a Principal Product Manager on Azure Functions. And today I'm here with Ramya and Paul. And so I'll let them introduce themselves as well and let you know what they work on. So Ramya, you want to go first?
Yeah, sure. Thanks, Eamon. Hello, everyone. Good morning. Good evening. I'm Ramya Aruganti, currently working as a product manager with Azure Functions team. My focus areas are about enabling functions on Kubernetes-based environments like ECA and AKS. Look forward to an amazing discussion today.
Awesome. Thanks, Ramya and Paul.
Hey everybody, I'm Paul Yuknovich. I also work on product with Rami and Eamon. I'm kind of a generalist. I work on a lot of the different areas, and I also work on microservices.
Awesome. So again, thanks everyone for joining. Before we kind of go deeper into the intelligent apps part with Azure Functions, just want to spend a couple of minutes just going through some of the core capabilities Azure Functions has. And hopefully you'll be able to answer some questions or ask some questions along the way, and then we'll stop and try to answer those for you as well. So if you do have any questions, please put them into the comments in the chat, and we'll try to pick those up and answer them as we go. So when you think about Azure Functions, there's really four capabilities that we offer inside of the service. And the first one is the integrated programming model. And what this allows you to do is to connect into all those different services that you want to get events from. And so if you're streaming events into event hubs and you want to be able to get those events in real time, if you're using Azure Blobs and you're uploading files and you want to get those, or you're trying to get information from a database, wherever that data is coming through, wherever that data resides, then you can get those events using our programming model without you having to write any code or do any of the plumbing work. And we'll get that event as it comes in, and we'll hand it into your business logic so you can just write your code on it. And then when you're done, we have output bindings inside the programming model allow you to send that data onto another service. So you could send it back for more processing, or you could store it into a database using our output bindings as well. So a lot of flexibility inside of our programming model with the ultimate goal of trying to abstract away the complexity and all of the work you have to do in plumbing all these different services together. We do that for you. So you just have to say, what business logic do I need to write on this event data as it comes in? So very powerful capability inside of Azure Functions. The second thing that Azure Functions offers is our end-to-end development experience. And so one of the critical things when you're looking at serverless and event-driven architecture is you want to be able to get your application into production as quick as possible and still be able to follow all the best practices from your local development experience through your CI/CD, through how you want to manage it inside of Azure, apply policies, security, and monitoring. And one thing we've done in Azure Functions is because it's open source, so all of our functions runtime, as well as our programming model and all of the integrations with our extensions to all the services are available. That allows you to deploy that onto your local machine using our core tools, and you'll get that full, rich local development experience when you're building inside of your dev machine. And what this means is that as you build it and you test it locally on your machine, the exact same runtime, the exact same integration, the exact same extensions are the ones that are used inside the cloud when you deploy it there as well. So your confidence when you build locally is high because you know it's going to run the same way in the cloud. But obviously, when you want to do deployments, we want to be able to use GitHub, Azure DevOps. We have built-in tasks that make it very easy for you to upload your code, package it, and deploy it into the Azure Functions service. So really kind of a lot of emphasis on this end-to-end development experience and trying to make it as easy as possible for you as a developer and your organizations to be able to build locally, test it locally, and then deploy it all the way through the lifecycle. The third thing that we offer inside of Azure Functions is a very flexible hosting option. And what this really means is once you build your application, you've built that event-driven workload that you've been testing locally, and then you want to say, where do I want to deploy this? And so with Azure Functions, we give you lots of different environments where you can deploy that application code to. So by default, you can just pick our serverless environment, and we can upload it there, and then we will get all the benefits of our serverless environments from scaling to 0 up to hundreds of instances. But you have different options on where you can deploy it as well. So if you already have a web app, and maybe that's your front end, and you want to do some event-driven responses to like orders coming in, then you can deploy that function app into your app services plans as well. So it'll run the same way. It's just now you have direct integration with your web application. And similarly, if you're doing with containers and you want to build microservices architecture and you want those to communicate seamlessly to each other, you can deploy our Functions app into Azure Container App environments as well. So that gives you the flexibility to deploy there as well. And because we're open source and our runtime and everything else that you build is open source, you can pick up all those components and deploy them into your own Kubernetes environment, either in Azure Kubernetes Service or in your local Kubernetes environment as well. So lots of flexibility on where you want to deploy your application based on what your overall workload requirements are and what kind of integration you want to do with the other types of services inside those environments. And then the last area that we focus on is really trying to reduce as many operational overhead as possible for you when you're building and managing these applications. And so one of the things we do is, because we can scale automatically down to 0 if there's no activity and no events to process, all the way up to hundreds of instances if you're under high load, and then manage all of those backend processes for you as well. So you don't have to worry about updating the operating system. You don't have to worry about updating the language framework. All of that is taken care of for you inside of the service, and really trying to focus on what's your business goal, what's your business application you're trying to run, and a lot of the operational tasks we try to handle inside of the service. And that makes it really cost effective for you, because not only are you paying when the service is running, but then the management of all of the infrastructure around it is also taken care of you for you by the service. And so another key benefit of Azure Functions. So the next thing, after you kind of know like the core capabilities in Azure Functions, you'll start thinking about what are some of the common scenarios that customers are doing with serverless. And it really kind of falls into these main categories when we talk with a lot of customers. And the first one, which we'll spend a little bit more time on today, is the artificial intelligence, machine learning, large language model, trying to build that intelligence into your application so that you can take advantage of all those capabilities and offer them to your end users in your applications that you already have. The most common thing we have today is basically trying to process real-time data events. And so if you're a customer, often what happens is there's data coming in from, your customers, maybe from IoT devices, from all kinds of places. And one of the things you want to be able to do is to react to that data as fast as possible so you can deliver business value quickly out to your end customers. And one of the ways to do that is to process that data as it comes in. And so real-time event processing, as streams are coming through, you can take action on those and deliver automatic updates to your end users. The third kind of category we see customers doing a lot with is orchestration and workflow. So one of the things that Azure Functions has is not only do we offer kind of short-running serverless type of functions you want to run, but we also allow you to write durable functions that are stateful. And one of the benefits of this is now you can actually build a lot richer type of applications that might require some state, that might be very long running, that might need to do aggregation, all of those capabilities, whereas typically you'd have to go to another service to get that workflow capability. All of that strong workflow through durable functions is built into the service itself. And so you can build a lot more flexible applications without having to write a lot more code by just using the built-in paradigms that durable functions give you. So very popular for customers doing kind of a range of scenarios. The fourth category we see a lot of customers doing, and something that you can get started very quickly in your organization, is trying to help automate a lot of the tasks that are going on inside the cloud. And so we generally put this into a bucket called event-driven automation. And so you could think about where alerts are happening, new types of resources are getting created, you want to assign policy, all kinds of those DevOps scenarios that you need to do as things change frequently in the cloud. You can now hook up functions to those events and be able to apply your organization's policies and tasks. They could just be scheduled tasks based on that. And so a very rich, powerful capability. And typically the languages you want to write that in is PowerShell or Python, and those are native into our application stack, as well as other ones like Java, if you need to, .NET, Node. From the IoT, I spoke a little bit about this earlier. A lot of our customers have a lot of data coming from IoT devices. You might be in a similar situation, and you want to be able to process those IoT events as they come in, either directly in the Kubernetes environment they might be running on, or you might also want to wait till those come through an Event Hub and be able to process them. But either way, all of these devices producing data, you want to be able to execute functions on those as they come in. And then the last category, which a lot of customers kind of get started with, is let's just build some native APIs for the mobile applications, for websites, and those serverless APIs you build in functions, they have that nice flexibility where they can be called by any type of application you have on the front-end client, but they also scale based on the load you need. So you get the flexibility of serverless, but you get a rich API experience as well, especially with our native integration with API management inside of Azure. So before I actually go to the next slide, let me stop and see if any questions might have come in. I know we kind of gave a few minutes there to see if anybody had any questions. I'll hand over to Ramya to have a look, see if any questions came in, and maybe we can answer one or two before we go to the next slide. So Ramya, anything on your side?
Sure, Eamon. So yeah, we can. There's this question here about like how can we leverage function apps to build intelligent apps, for example, plugin authoring. And there's another thing question as well attached to this. Like we're heavily into containers for running our application. So does function support this? So yeah, glad that we're discussing this topic, and this is something that I currently am working on, and and it's very apt to the topic as well. So we're talking about intelligent apps, and even just spoke about use case scenarios. So intelligent apps are disrupting every industry, like from various domains, right? Like customer service to business productivity to e-commerce, manufacturing, and so on. So and AI powered apps are not new. It's been in this in the ecosystem since many years. And to build these apps, developers need to be able to easily leverage existing models with their unique data sets, right? Like say, for example, some MC65 documents or systems of record, very specific customer feedback systems, some application data, which are very domain specific. So it's about integrating these custom domain specific data with the AI models, makes these apps intelligent. So, and we are constantly thinking on providing a platform so customers can easily integrate AI into their apps. And definitely plugin authoring offers a powerful way to connect these apps with AI. And leveraging services like Azure Functions will enable users to quickly deploy as cloud native apps. It makes them simple to operate and maintain such apps in a cost efficient way, which means customers get to pay only during the execution time. And on top of that, developing these plugins and apps using GitHub code spaces and GitHub Copilot gets even better, especially during their development cycle. So I also have a reference architecture slide. In fact, so even could you share that slide? It actually captures an architecture where like functions and the plugin in a functions in a plugin authoring scenario. This is a doc search app. So the user essentially posts a query looking to search for a specific doc. And it's like there is a front-end web app hosted on container apps running on container apps microservices environment. And in the same cloud native microservices environment, like there's a function app that is deployed, and this is also on hosted on this container apps environment. And it's essentially like a HTTP. It could be a HTTP trigger. So this function app is connected to Azure OpenAI service, which is hosting like a text embedding ADA model, and which essentially helps to search for the files. And the core files are actually stored in a FaaS service called Azure Database for PostgreSQL. It's enabled with VectorDB, which helps with storing of these embeddings, and also retrieving and responding back with the nearest accurate docs that the user is intended to retrieve. So hopefully this gives a view about, here if you see functions are executed only when there is a query that the user requests, and then it processes the request, connects to the OpenAI service and the database, and returns the results and scales back to zero. And since like the user is also asking about, can functions run on containers? So yes, there are several plans available today where functions can be hosted on containers, and specifically during May 2023, we have launched functions on Azure Container Apps in public preview. So this enables users to host function apps as containers along with other microservices, APIs, web apps, or container hosted programs. So, and like Eamon mentioned, so functions on container apps brings that programming model, the extensions comes with the triggers and bindings, and also has a seamless integration with Keda. So yeah, we're actively working on bringing out new capabilities, and like the seamless integration with Kera is already out, and we're also working with Dapper, which is pretty popular and most efficient way to use in our microservices environment. So that will be out soon. And VNet internal and managed identity, some of the security features will be out soon, and we're also trying to build the seamless integration with Kera with several other triggers, right, like timer, blob, and Cosmos, and durable. And today, customers can use AZCLI, Bicep, Azure Portal, Developer CLI, CI/CD tools like GitHub Actions and Azure Pipelines to deploy their apps on container apps. So yeah, check out the service and features that are available, and yeah, do let us know your feedback as well.
Awesome,
Yeah,
Rami. Yeah,
hopefully,
definitely
yeah.
appreciate it. If you're trying, I mentioned about running functions on container apps. It's in public preview. We're trying to get to general availability. Would love you to kind of try out building function apps there, integrating, like Rami said, with containers, and letting us know how that's working and if anything else we can do before we go general available. So given that, that's a good transition, Ramya, into what can you do with intelligent apps with Azure Functions? In that demo you showed there, kind of a very powerful common scenario where customers are trying to bring their own data. But there's kind of a set of scenarios that we see customers trying to build. A lot of them are in POC state. Probably a lot of you out there looking at this now are also trying to figure out, how do I bring intelligence into my applications? What is kind of Copilot technology I can bring? How do I perform search over my own data so I can bring that knowledge to my end users? How do I build chatbots that actually have that rich experience? And so there's a set of scenarios we're seeing customers do, and they kind of fall into 4 categories at the moment. One is, we see customers kind of building serverless endpoint to support chatbots / assistants with Azure OpenAI. And so this is kind of, how do I bring that rich LLM technology that we offer through ChatGPT and make that available to your end users, and supplementing that content with your own data. The second one is, you may have lots of data in your organization. You may have a lot of support data. You might have a lot of information about customers. You might have a lot of documents in your organization. All of that kind of content, what customers really want to be able to do is perform intelligent semantic search on that content as well, and then be able to add that content into these larger LLMs to be able to do an additional kind of search and semantic query on top of that. And so what that really means is there's a standard pattern we see a lot of customers doing now, which is called retrieval augmented generation. And all that really means is this allows you to bring your own data in, create embeddings, store it inside a vector database, either put it into Azure Search. You can bring your own vector database like Pinecone, but you'll store it inside of that database. And then when you do a search on that, it'll actually convert them into embeddings. It'll do that semantic search for you, give you the results plus the content, and then you can hand that off to the LLM so that they can give you a better response based on that knowledge that you just retrieved. The third set of scenarios we see customers doing is building plugins. And so this is relatively new. Some of this is kind of in beta. Some of it's available now, depending on where you are with your Azure OpenAI subscription. But the idea behind this is, a lot of times the knowledge the LLM have may not be up to date. You might want to be able to pull in real-time information to be able to supplement that content that the LLM is providing. And with plugins, it allows you to do integration into other services. So maybe you want to be able to pull in real-time, stock market information, or pull in weather information, maybe booking information. And so you can supplement the LLM through the OpenAI plugin, so that if it doesn't have the relevant information, it will call you through this plugins capability to bring that relevant information back to you as a customer. And then what a lot of customers are doing is actually training their models. So they have their own models they're trying to build, trying to take advantage of everything that's going on in the LLM space with their own algorithms, but they need to be able to bring their own data in. And so they spend a lot of time parsing data, trying to get it into the right formats and bringing that data into the model so that then they can offer that out to end customers. So when you think about those 4 large scenarios, you want to start thinking about, which one of those might be good to run in a serverless environment, event-driven architecture using Azure Functions. And the core set of capabilities we offer out of Azure Functions to help with these scenarios is that we allow you to kind of try out things, and then we'll dynamically scale based on the needs of your intelligent app. And so, maybe it's not used that frequently. You're trying it out. Maybe it's only popular during the day, and then it's not used at night. But because we have this dynamic scaling capability, it'll scale down to 0 when it's not used, all the way up to those hundreds of instances if you have really heavy workload. And so it allows you to kind of be able to do that work knowing that you're only going to pay for what you actually use inside of that intelligent app. I mentioned earlier our programming model. But when you think about our programming model and then you try to align that with retrieval augmented generation, what's really happening is all of this data is coming in. Somebody just opened up a support ticket, somebody just placed an order in your environment, somebody just uploaded a document, added a file. As those events are happening, Functions is really built to actually get those events and then be able to process them. And so a lot of times you can pull in all of that information you have in your organization and be able to store that into a vector database using that semantic search capabilities with embeddings. And so this is a way for you to kind of move into the intelligent space, leverage your data in an intelligent way, but leverage Functions to actually get the data in and store it and retrieve it for you. The third thing that Functions is very good at is this, what we call HTTP trigger support for building your own APIs. And so when you think of that first scenario up there around, I want to kind of have an endpoint where I can call into the ChatGPT. I want to supplement that with my own data. I want to be able to do a lot of things, but expose that as an API. So my front-end clients, my website, my mobile app, whatever client you're exposing to, can actually call into that API and give you back that information. And so our integration with API management allows you to really kind of have that nice integrated API experience on top of these large language models, on top of your AI integration that you've built. The fourth thing, which I mentioned a little earlier, is this durable functions orchestration capability we have. And this has a really powerful capability, not just to do state management, but to do long-running tasks, to do tasks in parallel, to aggregate the results back. And when you think about trying to build intelligent applications, a lot of times you need to be able to, understand the history of what's going on. Maybe you need to call different services to get that query information back. You want to be able to process data and then store it. All of those kind of capabilities that require state management might be long running, might need to do things in parallel and aggregate results. So if those things are part of your intelligent app, then Durable really gives those capabilities out of the box for you, and you can start to build these more rich experiences that you would need for those intelligent apps. And then the last thing I think is important is, because of the portable capability I talked about earlier of the Functions runtime, when you build these intelligent apps and you've tested them, they're offering value to your application, to your end users, then you have the option of, where do I want to deploy these? And this can become important because maybe you have existing applications, existing workloads that are deployed in app services. Maybe they're deployed in serverless, they might be in Kubernetes, or they could be in container apps that Rania talked about. But now you can bring that intelligent app to that environment where your existing application might already reside, and then be able to add intelligence into it by kind of building this native integration using Azure Functions. So those are some of the kind of scenarios we can do with Azure Functions for intelligent apps, as well as what capabilities we offer to make it hopefully easier for you as a developer and an organization to get started. So with that, I'll maybe check to see if there's any questions. Paul, I don't know if anything came through the comments, if there's any questions you see that.
Yeah, I got a good one, which is someone asked, what's the way forward with InProc? Any guidance on v4 and isolated versions? So this is a great one. It's a kind of a complex question. I'll take it in a few different ways. So as a lot of you know, the functions model started out being completely in process, so that your user code and our function service runtime code all ran together. So we kind of touchingly called that InProc. And over the years, we've really evolved all the way to the functions v4 model. And we've introduced in .NET and now all the languages an out-of-proc model, or we can call that the isolated process. Really, to kind of keep it simple, at this point, we'd recommend that all new development is done using the version 4 or later, and then also using the isolated model. And in terms of like why we'd want to do that, isolated really kind of buys all of us some agility. because before, if we had a version of Azure Functions that was written, say, on .NET 5 and then later .NET 6, that would lock in what your user code would also have to be written in. So by separating and kind of externalizing the processes, the Azure runtime for functions itself can be decoupled from your user code. And that lets your code be more agile and use the latest version of .NET, which has been 7. Now we're all the way to .NET 8. It also lets us take advantage of more LTS versions. So like 6 is an LTS version of .NET, and 8 will be the new LTS. So it just lets us keep up to date. Now, at the same time, Isolated brought a couple challenges, like using the type system that you wanted to use for HTTP or for things like service bus messages. That got a little bit harder. But the good news is, as you've seen maybe from the roadmap updates from Matthew Henderson, we've really brought the mojo back, where you can use full ASP.NET Core. You can use the same HTTP types that you're used to using. You can also use actual SDK types from the Azure SDK, so you can kind of deserialize like right into a service bus message. So all those things are now possible, and hopefully that makes it a lot easier to go from the in-proc model to the isolated model, because you're not losing that type fidelity anymore. In terms of guidance, we have really good upgrade guidance on version 1, version 3, all the way to version 4. There are a small bit of breaking changes that you want to navigate around. We also have a tooling. There's the .NET, I think it's called the Upgrade Assistant, and that's a really good one to know about. It can assess your code, and it even understands functions code and gives you a lot of pointers on how to make that migration go smoother. So yeah, just to summarize, hopefully at this point, all new development we're doing with V4 later and isolated. That's really the direction that Azure Functions is going, for the reasons I mentioned. And for your existing code, we have some help on the way now with the .NET Upgrade Assistant.
Awesome, Paul. Yeah, lots of great things happening there. Definitely, if you guys get a chance, again, please try it out, give us feedback, ask questions. We're just trying to keep, innovating in this space if we can, and make it better for you kind of building applications. So there is a demo that Paul built, actually, that has all this content to get started when you're trying to build an intelligent app with Azure Functions. And so the scenario is simple, and it's up there in that AKA ms/LangChain. So if you want to go there, it's up on GitHub. But it really shows you how to build a simple application by leveraging some of these orchestrator SDKs like LangChain or Semantic Kernel that's out there to do complex integration with different AI services. So it can connect into Azure OpenAI. You might want to connect into other services. But at the end of the day, what it really does is it allows you to take a prompt from a customer, and then it'll inside of Azure Functions, it'll integrate with LangChain or Semantic Kernel, and to be able to call into Azure Cognitive Services like Azure OpenAI, get the result back, and then send that back to your end user. And so this is kind of a basic scenario that you could get started with and then be able to build on as you go forward. And so a really nice scenario that's up there. And the good thing is it's kind of AZ developer friendly. And so you can actually use the Azure Developer CLI and be able to not just build and test it locally like we talked about earlier, but be able to deploy it up into Azure and have a working end-to-end kind of starting point for you to build on as you go forward. So again, nice sample up there if you want to get started with Azure Functions and learn more about intelligent apps. So the last slide, so hopefully this kind of gave you an overview of what's available in Azure Functions, how you can build intelligent apps, what are good types of scenarios that might work well with Azure Functions and the capabilities we have. And there's a bunch of learn more content as well. Hopefully you get a chance to go to Ignite or watch the sessions online. There's a lot of new things happening there. We'd love to kind of get feedback. And then obviously, if you want to get started, go to Azure Functions documentation, good content. And I put a link to the reference architecture as well. So you can go look at samples, how to build Azure Functions. So with that, I'll kind of stop the stream. Thanks to Ramya, thanks to Paul for joining. Thanks really for everybody for watching the video. Hope you learned something and keep the engagement going as we go forward. So thanks a lot, guys, and we'll see you next time.